Okay, so here's a video over integrals and using substitution, or the u sub. And u is just some variable. It's just one that has kind of just been picked to be the go-to, just to give it a nice name to know and all that other fun stuff. So how do we actually use that? Okay, so say you want to integrate some function like x times x squared minus 4 raised to the 40th power, and you see that and you're like, say what? But so anyway, since it kind of looks messy, looks complicated and all that stuff, just since your variables are x and you're doing the integral with respect to dx and all that, to make things easier, to clean things up, try to substitute in something. And so, like for an x, try to find something, in this case, with the u sub or whatever, you want to find a variable u, or set some part of the x equal to the u, so that way you can just substitute it in and clean things up and all that. So really, as far as figuring out a u to use, the more problems you do, the easier it'll be to find a u, or to be able to pick a u to use. So for this, let's just set u equal to the x squared minus 4. And whenever you just take a derivative of that, that would just be 2x. Alright, so du would be equal to 2x times dx, and so then dx would be equal to du times 1 over 2x. Okay, so like the whole point of doing that is to figure out stuff that you can sub in to make things easier on yourself. So if you look in the equation, we have our u, which is what we defined, and we have a dx, which we also found right down here on the very bottom. So these are two pretty handy pieces of information that you're going to need to be able to do this. Okay, so now that we have those, we can just go up here to our integral that we're trying to do, and just substitute in what we know. So it'd be u to the 40, and our dx was du times 1 over 2x. Alright, so if you look, since all this is being multiplied, we have an x up here, which would be in the denominator, and we have a 2x right there. Alright, so those x's, or the x, will be able to cancel. So we can rewrite that as u to the 40 du, or times du, and times 1/2. Well, the 1/2 is a constant, so you could pull it out. It's going to be times, you do the 1 over 1 plus n, and 40 was our n, and so oops, it's going to be the u to the n plus 1 Alright, and since we get a du by taking the derivative, so whenever we do the integral, the du is just going to disappear. So, that should just be equal to u to the 41 over 2 times 41 is going to give us 82. Oops. Okay, so now that we have that, we can just go back and substitute in our u, since we have u. And so that was x squared minus 4 to the 41 over 82. So it's, not too hard. Seems kind of, like it should be kind of easy. So that seemed pretty easy. But one thing that you got to watch, which I'm pretty bad about, up here, since we were doing the integral, and it's an indefinite integral. For our answer, we need to throw the plus a constant in there. And so, it's just one of those things that you just really need to pay attention to what you're doing, because whenever you go through and do the derivative, you're going to have a constant, and or when you do the integral, you're going to have a constant, because the derivative of a constant is 0. So just always make sure that if it's an indefinite integral, which is the integral sign with no numbers, that you put a constant in there to make sure that it's actually 100% correct. Okay, so just another quick example of something that looks a little bit weird. We're wanting to integrate sine of 4x dx. Okay, so do the u substitution, and just by trial and error, or just by experience, come out with u is equal to the 4x. And then go through and do everything. Take the derivative of u with respect to x, which would be 4. So du comes out to be 4 dx whenever you multiply both sides by dx to get du by itself. And so then if you solve for dx, you're going to get 1/4 du. And so that's another little piece that we need to know. So whenever you do that, the integral of sine of u, and dx was 1/4 u, or du. As you can see right there is what we found. And so the 1/4 is a constant, so we can pull that out, and so we'll have 1/4, and then we're integrating the sine of u times du. Okay, well, from the trig videos that I put up, if you take the cosine, if you take the derivative of cosine, you're going to get a negative sign. So if you take the derivative of a negative cosine, you're going to get a positive sign. So that would be 1/4 times a negative cosine of u, and the du goes away, but since we integrated, and it's an indefinite integral, make sure you put a constant in there, which is what I often forget. And so that would be negative 1/4 cosine of u, and right up top we said that u was 4x, so you can just plug that in there, plus a constant. So this one right here should be your answer. Okay, so here's one more quick example. we're wanting to integrate x plus 3 over x squared plus 6 squared, or 6x squared dx. And over here on the right side, I've already set out, there's the u. And coming down, found the dx. And so dx would be equal to du times 1 over 2x plus 6. But if you look, the 1 over 2x plus 6 could factor, you can factor out a 2 out of the denominator, and you'll have du times 1 over 2 times x plus 3. And if you look, the x plus 3 right there, we'll be able to cancel with the x plus 3 right up here. Once we actually go through and plug everything in, you'll be able to see that. Okay, so here you can see that I just rewrote the equation, plugging in everything that I found. The x squared plus 6x squared, I just subbed in u, which I'll set over there to the right. And for the dx, I just plugged in this dx with the denominator factored out. So you can see that x plus 3 and that x plus 3 are going to cancel. So now we can have, we're going to have 1 over 2, so we can factor that out, or pull that out of our integral. And we're going to have, 1 over u squared times du. And you have 1 over 2, the integral of u to the negative 2 du, because if you have a, like, say, u squared in the denominator, that's the same thing as saying that's u to the negative 2 power. So you can get that. And so then you can just do that'll be 1 over 2 times, look at the n, which is on the u, so it's going to be negative 2 plus 1 times u to the negative 2 plus 1, and the du goes away. So we're going to have 1 over 2 times negative u to the negative 1. And so that's going to leave us with 1 over 2 times, we're going to have a negative u over 1 plus our constant. So we just carry this over to the next screen so you can actually see it. Alright, so we had our 1/2 times negative 1 over u plus our constant, and I went ahead and brought over our u as far as what we substituted in for it. So just go through 1/2 times negative 1 over our u, which was x squared plus 6x plus a constant. So then whenever you go through and actually multiply that out, you'll get negative 1 over 2 x squared plus 6x plus our constant. And so there it is after we substituted in and did all the integration, and that's what we came out with. So I'll have some more videos coming up shortly.